Okay, this lesson is about energetics of chemical reaction. Chemical reactions, when proceed, new substances are formed. But all changes are not chemical changes. For chemical changes, something occurs at atomic level. Remember, atom is so small a thing. A full stop contains trillions, such a small a thing, atom. And a change has taken place at atomic level. It means a substance got dismantled at atomic level and then it is reunited, remade. So that is the reason when a chemical reaction occurs, a new substance is formed and its properties are entirely new. In this particular video, you'll find out what chemical reactions are, why some chemical reactions emit heat as they go on, like combustion takes place and surroundings are warmer, and why some chemical reactions when go on, surroundings are cooler, that is endothermic. So we'll see about exothermic, endothermic, we'll see about the energy level diagrams of exo and endothermic reactions, and we'll find out what the enthalpy, the word enthalpy which is being replaced in thermodynamics for energy, and how the activation energy is needed, energy absorbed, energy released, energy profile diagrams, and then actual values we'll put in to find out how much exothermic or how much endothermic. And we'll see some general exothermic reactions and their applications, and some endothermic reactions and their applications. So this video, you'll find out, covers all this detail, the whole chapter regarding energetics of a chemical reaction. Now, I said a chemical reaction basically is a combination, a chemical combination. Chemical reaction, reactants combine to change into product. Reactants mean those substances you are starting with. You have hydrochloric acid in hand, you have zinc in hand, they are your reactants. But when you mix them together and reaction goes on, that is the product. So chemical reaction basically is a change of reactants into products. And during the process, entirely new substance with new properties, no relationship whatsoever with the reactant is seen. Like the best example can be, we all know sodium is a metal, very reactive, kept under kerosene oil, because with moisture it will catch fire, it can explode. We cannot think of putting a sodium piece into the mouth because with moisture it will explode. And chlorine is poison, poisonous, toxic, used by some bad people in wars to kill people long ago. Chlorine, such a terrible poison. We use parts per millions of chlorine in swimming pools or disinfectant in water, purifying plants and other things. But remember, sodium chloride, the table salt, the flavor, the best spicy thing in spicy foods, sodium chloride is made up of these two, sodium, metal and chlorine gas. That speaks volume about chemical reaction. That chemical reaction changes nature so much. Why? Nothing happens by magic. It is a chemistry behind that. Basically sodium is broken to atomic level, chlorine is broken to atomic level, and then after that exchange, we know that bond making has taken place. So first bond breaking and then making, but bond breaking at atomic level and then bond making at atomic level. All chemical changes, bond breaking and then bond forming. You'll find out bond breaking, you want to break the bond, then energy is needed to break the bond, because bond mean an electrostatic force of attraction, either by ionic metals and non-metal ions, or between two covalent non-metal species, they are locked in electrostatic force between the nuclei after two joining things, and the electronic cloud they share, there is electrostatic force. Whatever bond need to be broken, and that needs energy. They need to separate off into atoms. So you provide energy and their energy increase, their profile energy level increase, and at higher energy levels when they collide, that collision is fatal collision, because that will break their bond. And once their bonds are broken, they are at higher energy level. Then they lose energy to the surroundings, obviously from hotter body to colder body it flows. And at a certain level, they remake. So the bonds are formed, like in this case, sodium metal, chlorine gas. Individual, they are into atomic form, and later on, if they are sent into an ionic bond, it means it is between sodium and chlorine. Okay, So chemical reaction occurs by bond breaking. Look at that, hydrogen molecule, water molecule, methane molecule, but two hydrogen atoms now. Water has two hydrogen atoms and an oxygen atom, or methane has one carbon atom and four hydrogen atoms. Now it is shattered into atoms. So bond breaking is always endothermic. And when first part of the chemical reaction, any chemical reaction whatsoever is endothermic, enderthermic, heat taken in, because that heat is needed, so their energy level increases and their collisions got successful at a certain energy level. Okay, like now we are standing in this room, there's plenty of nitrogen and oxygen, 80% around nitrogen and oxygen, they're knocking into each other thousands of times per second, but there is no bond breaking taking place, because if the bonds are broken, nitrogen will react with oxygen and toxic nitrogen oxide will be formed, like N2O or NO2, toxic, poisonous. But nothing happens even in the sunlight, because that amount of energy, minimum amount of energy, we call that as activation energy, the amount of energy needed or absorbed into the bonds of the reactants, so the collisions become successful. That is called activation energy. So since nitrogen is maintaining its properties, oxygen is maintaining its properties, we are breathing it air, oxygen is being utilized, nitrogen is acting as a solvent. Reason they are maintaining originality, reason their bonds are not broken, because enough amount of energy is not there. Even the sun is providing the calculated amount of energy, so it's not a reaction taking place between nitrogen and oxygen. Okay, may take place a little amount, or in car engines or vehicles or power stations, high energy where there is produced, this reaction may take place. Mean bond energy is provided, but normally it's not taking place, thanks God, and we are safe, we are using air as a mixture. Bond making, on the other hand, releases energy, because at a higher energy level their bonds are broken, though they release energy, and energy released, then the atoms come closer and they may develop an ionic bond or a covalent bond or a coordinate bond. But at a lower energy level, when they come closer, an electrostatic force of attraction can develop. Okay. Now, I said chemical reaction is the change of reactants to product, but it's not a physical change. Reactants absorb energy, and that absorbed energy breaks their bond. That is the minimum amount of energy needed to start a reaction. Bond breaking always endothermic, and bond making always exothermic. They release energy and then they approach for a bonding status. Look at that, atoms, carbon, 4 hydrogen turn into methane, bond making when shown. So it is split basically, endothermic and exothermic, exit given off. Now minimum amount of energy needed to start a reaction, that is called activation energy. Once the activation energy is provided, bonds are broken, then bond making start occurring and energy is released. Okay, now it depends on overall a reaction is exothermic or endothermic, because exothermic is the one in which no doubt first part is endothermic and the second part is exothermic, but the bond breaking in this case has absorbed less energy and bond making has released, the word released has given off more energy. As a whole, surroundings are getting a surplus energy and they are getting warmer and hotter, like combustion reaction, okay, like neutralization reaction, like displacement reaction. You see, reactants, products, they are taken as system, and reactants and products, the system, when reactants react and products are formed, energy is given off to the surroundings, continuously being provided to the surroundings. Surroundings at a higher energy level mean surplus energy is being gained by them, mean input is less and output was more, surroundings are warmer, then that case we call it exothermic. On the other hand, if it is endothermic, then it means bond breaking has consumed more energy and bond making is releasing less energy. So surroundings are being depleted of the energy constantly, that is why they are getting cooler, and endothermic reaction needs a continuous supply of energy. Exothermic reaction, on the other hand, the released energy is also acting as basically the activation energy. So they become spontaneous. You'll find out that if we draw energy profile for an exothermic reaction, we need to show energy axis and the course of the reaction, and the certain initial level of the reactants and the products, and basically the absorb energy and release energy. Like for an exothermic reaction, energy increase like this, and here goes the time, the course of reaction. Now we'll show this thing that reactants basically got a certain energy level. They cannot have a zero because they are made up of atoms and the molecules. They have internal energy of their own, so they have a certain energy level, supposedly this, and the reactants are right here. Like in this case, I can take an example of nitrogen reacting with hydrogen, N2 and H2 reacting together. They have this energy level. Okay, we can call this as H naught. The word H for enthalpy, for heat, energy. Okay, we use the word enthalpy basically for heat in exothermic reactions or endothermic reactions or in thermodynamics. So this is the energy level, original energy level. Suppose at this energy level the reactants are mixed, they are not colliding, they are colliding but they are not undergoing a chemical reaction because the minimum amount of energy is not being provided. But you increase in energy, supply energy from surroundings they get, you will find out from surrounding they are getting energy at a certain energy level. Suppose this, here they have sufficient amount of energy, and that sufficient amount of energy which is needed for this reaction to start or collisions become successful is called activation energy. So here bonds are broken. It's not N2 I have written or it's not H2 I have written, rather these are hydrogen and nitrogen, atomic state. Now amount of energy that is being supplied can be monitored like this, and absorbed energy is shown by a plus sign. This is activation energy. Now here the collisions are getting successful. This is the minimum benchmark. Before that, all these energy levels, these collisions are successless collisions. But here they are producing what? At this energy level, collisions are fruitful collisions, successful collisions. And then after bond breaking, the first part was endo, you'll find out energy is released. Now if it is exothermic reaction, you know from the data, you know from the fact, if it is exothermic reaction, then we'll make a curve for release energy, and you'll find out for an exothermic reaction energy is released. Now we need to bring it down from the original level it has started. To show off this thing that energy released is more, check out, energy released is more. This was original energy level, it has absorbed energy from this point to this point, we call it as H1, and then from H1 start releasing energy after bond breaking, bond making release energy, and that released energy we'll find out that amount of energy which is released shown by a negative sign. Look at that, from this point to this point is released. This is H2. So absorb energy, bond breaking, first part, absorbed energy, and bond making has basically is releasing energy, energy released. And you can find out absorbed energy is less and released energy is more. This part shows that is continuously being added to the surroundings, and we call it as change in energy, change in enthalpy or change in energy. So change we show with delta, that is delta H, and you can find out energy released is more and energy absorbed is less. So bond broken minus bond formed, you'll find out the answer coming in negative, and that shows the reaction has basically exit heat, and we call it as exothermic reaction. Look at the energy profile diagram again. Energy level of the reactant, gradually they are gaining in energy. At this particular energy level, they have gained from H0 to H1 enough to break the bonds, and here the bonds are broken, the activated complex, the activation energy, and then the energy is released. And the released energy, look at that, the released energy is more. So you bring it down from the original level, and that shows your change in energy. So we call it as enthalpy change, delta H. That is enthalpy change. And enthalpy change clearly shows that input was less and output is more. You can also see from this point that, look at that, release energy is more. Okay, so difference of these two, absorbed energy, bond broken minus bond form, is given an exothermic reaction. Okay, now many reactions are exothermic. They are releasing energy to the surroundings. For example, combustion. The word combustion means burning. That is exothermic reaction. Like fuel burnt, methane gas burnt, petrol burnt, energy released is utilized by machines. Or the most important thing, respiration. Whatever food we eat basically is being digested in the digestive system and then absorbed by the bloodstream, goes to cells, and each and every cell burn this food, oxidize this food, and energy released. That is why we are utilizing it for useful work. Okay, so exothermic reaction it is. Respiration is exothermic, means its bond breaking has consumed less energy, but bond making has produced more energy. So respiration, another reaction, releasing energy. Then with displacement reaction, some facts to keep in mind. Displacement. A more reactive metal displace less reactive metal. Always you will find out exothermic reaction. The beaker is getting warm. A zinc rod placed into a copper sulfate solution, zinc sulfate and copper separated out, but the beaker gets warm. Fact is what? Exothermic reaction it is. Okay, but combustion, respiration are most common exothermic reaction. That is why in a jungle fire, somehow the combustion reaction occurred, accidentally it has started, but then it becomes spontaneous fire because energy released is acting as activation energy, difficult to control. Like Californian forest fire and so many others, they spread and they are not controlled after a huge effort even. For months it goes. Reason is heat released is acting, surplus energy acting as an activation energy. So exothermic changes, bond breaking, bond making, that I said is a story of a chemical reaction. But bond breaking has absorbed less energy, bond making has released more energy. And that is why surroundings are at gain always. Okay, the respiration we have energy, combustion we produce, and that is why the energy is utilized for cooking and everything, and driving vehicles and power stations, turning water to steam and running turbines, basically started from what? Burning coal or oil. These are exothermic changes. Okay, exothermic changes got spontaneous because they are being provided the activation energy. In terms of bond breaking and bond making, again I'll stress that bond breaking absorb energy, that's endothermic. Bond making release energy, that is exothermic. But overall a reaction depends on that bond breaking has consumed less and bond making has released more, that makes it as exothermic change. We'll see exothermic change, endothermic changes afterwards.